Hey guys, today we're talking about geometric proofs. Okay, in my class, I like to use these four guiding questions anytime we're asked to do a geometric proof. Okay, the first thing we look at is what information are you given, right? We have to be given some type of information in the problem, like maybe like we have a midpoint, or we might be given some parallel lines. Okay, your given information is where we start each of these proofs. Okay, so because of that given information, what do I know is geometrically true? So what things are congruent, right? What things are equal? Do things add up to a total? Okay, do things like this happen? What can you say geometrically about that truth, about that given information that we know? Okay, and then next we look for the picture. Okay, at the picture, what else is true? Okay, are there vertical angles? Are there two angles that add up to 180 or 90? Right? Are these things perpendicular? Look at the picture and see what you get next. And next, can you find a relationship that links your given to your proof, the thing that you're asked to prove in the end from where you start? Okay, so the given is where you start and the proof is where you end. And you have to be able to build that bridge that links the start with the end. Okay, so right now we're going to prove the vertical angle theorem. Okay, this is a good way to start for these proofs. We're going to use deductive reasoning. We're going to use theorems and all kinds of good stuff in order to do this. Okay, and it's only 6 steps long. So like I said, our first step is always writing down your given. So our given information here is that segment AB and segment CD intersect at this point we're calling E. Okay, so this picture here is what we have. Okay, this information is given to us. So the reason we're able to write down this statement, okay, is because it's given to us. So now let's look at where you want to go, right? We want to show that angle AEC, we want to show this angle here is congruent to angle BED, or having the same measure as this angle down here. Okay, so this is our goal, is to show that these two things are congruent. So if this is our goal, then we need to somehow introduce these two angles into your proof. Okay, so the first thing we're going to do is maybe we notice that these 3 points, A, E, and B, are collinear. Okay, and then this is, of course, an angle. So one thing that we could say is that these two angles add up to 180. Okay, this is a true statement because we have intersecting lines. So the measure of angle AEC plus the measure of angle CEB equals 180. Okay, and that is because these points are collinear. Okay, so this is a straight line, which means any angles formed have to add up to 180. Okay, because there's 2 of them, that makes these a linear pair. So we're using the definition of a linear pair in order to write that down, that geometrical relationship. Okay, linear pairs are 2 adjacent angles that form a straight line, so they add up to 180 degrees. Okay, so now looking at our other one, okay, our other friend here, we're going to use the same type of idea, is that now we have D, E, and C. Okay, this is our straight line. So we're going to have these 2 angles that add up to 180. So the measure of angle DEB or BED plus the measure of angle BEC, okay, also adds up to 180. Okay, for that same exact reason, these things make a linear pair. These are 2 adjacent angles that form a straight line. So that is the definition of a linear pair. Okay, so now we're going to use some of our brain. Okay, and we notice hopefully that both of these things add up to 180. Okay, so if both of them add up to 180, that means that these 2 angles sums, right? The sum of these 2 angles are going to be equal also. So I'm going to take this purple statement and I'm going to replace it here instead of the 180. Okay, so I'm using, whenever I'm replacing with something that's equal, actually this should start off with purple. So the measure of angle AEC plus the measure of angle CEB, okay, the purple stuff, is equal to the pink stuff because they both equal 180, therefore they can equal each other. BED plus BEC. Okay, so we are using substitution. We have replaced on 180, right? We replaced this purple 180 with all this pink stuff. Okay, because they both equal the same thing. They both equal 180, so we are replacing 180 with what it equals. So now hopefully maybe we notice, right? Both of these angles have this CEB, right? Both of these linear pairs have this angle which is in common to them. Right? So what I'm going to do, mathematically speaking, if I had like x, or you can't even see that, if I had an equation x plus 5 equals y plus 5, right? I am adding the same thing to both of their sides, right? In this case, both of these sides have angle BEC added to them, both of them. I can subtract from both sides, right? So if I'm using some type of an algebraic thing here, in this case I'm using subtraction. This is the subtraction property of equality. Okay, so I am subtracting from both sides, and as long as I do it to both sides, right, then that is mathematically legal. So now I'm going to end up with the measure of angle AEC equal to the measure of angle BED. Now notice my proof right here. Okay, that's really close to what I want to show. The only difference is this congruent symbol. Okay, so measures equal. So maybe this is stirring your memory, maybe not. Maybe you've never seen this before in your life and this is the first time. But there is something that says if the measures of two angles are equal, then the actual angles themselves are congruent. Okay, if the measures are equal, then the angles are congruent. Okay, so if measure of angle equals a measure, then that means that the actual angles themselves, the pictures, right, are congruent. Okay, and that's something called the definition of congruence. So I'm just going to write that out rather than shorthanding it. Definition of congruence. If it will let me. Congruence. Okay, and that is the proof of the vertical angle theorem. Okay, so vertical angles are congruent is what the vertical angle theorem says, and this is why. Okay, because of all these reasons. So we can add up two angles to 180, and then there's a secondary pair, and you subtract them, and you have congruent angles. So let's try to apply this to one other theorem, okay, known as the alternate interior angle theorem. Okay, which says if parallel lines are cut by a transversal, then the alternate interior angles are congruent. Okay, if parallel lines are cut by a transversal, then alternate interior angles are congruent. So look at angle 2 and 4. Angles 2 and 4 are definitely alternate interior angles. They are in that same position. So we're going to show that these are, in fact, have the exact same measure. Okay, that these angles are congruent. So we start by knowing that the lines are parallel. Okay, we start by your given information. Your first step is always writing this down, and the reason is because it's given to you. Okay, so before we get to the theorem, we have a postulate. Okay, so postulates don't have to be proven, and they are congruent always. So there is a postulate known as the corresponding angle postulate. Okay, we're going to use this corresponding angle postulate in order to write down some corresponding angles. Okay, postulates are always true. We don't ever have to prove them. They're so basic that it's the same. So if we're looking at this picture here, hopefully you're able to recognize that angle 1 and angle 4 are in a corresponding position. Okay, so angle 1 and angle 4 are corresponding angles. So that's what I'm going to write down here, is that angle 1 is congruent to angle 4. Okay, always when we have parallel lines, right, because the lines are parallel, you have corresponding angles that are congruent. So now looking at your picture, what else is congruent? Okay, and from our steps up above, hopefully you're recognizing angle 1 and angle 2. Right? Angle 1 and angle 2 are never not congruent. Okay, these ones are vertical angles. So from before, we can say that angle 1 is congruent to angle 2. Okay, so these are vertical angles. So we are using, like we did up above, we are applying the vertical angle theorem. Okay, so the vertical angle theorem is what allows us to write down that we have two angles which happen to be vertical, right? And this is from your picture, that angle 1 and angle 2 are congruent. Okay, so basically this is all we need, and now to use our brain sum to say, okay, I have angle 1 is the same as angle 4, and angle 1 is also the same as angle 2. So if 1 is the same as 4 and 1 is the same as 2, that must mean that angle 2 is the same as angle 4, because both of these 2 and 4 are equal to or congruent to that same middle angle. Okay, this is the link. Okay, and this is actually something called the transitive property. Okay, if 4 is the same as 1 and 2 is also the same as 1, that means 4 has to be the same as 2. Okay, so that's the transitive property, and that is exactly what we were asked to show. So the last step in your proof is always the thing that you're asked to prove. Okay, and sometimes we put a little box down here at the end, meaning that we're done. Okay, so using those 4 guiding questions from your given to your knowledgeable information, to your picture, to the link, right? Angle 1 is the link. We can do these geometric proofs of parallel lines cut by a transversal.